Hello, class, and welcome to Lesson 8.0. We're combining Unit 7 and 8 for the last unit test, and Unit 8 deals with trigonometry. So today's title is Intro to Trig. Now, before we step into what we call SOHCAHTOA, or cool things we're going to learn in this unit, we want to review Pythagorean theorem, because Pythagorean theorem is connected to trigonometry. In terms of some of the side lengths and measurements we use. So let's take a look at our warm-up. So for those who forget what Pythagorean theorem is, that's c squared equals a squared plus b squared. I know you learned that in grade 9. Okay, or in grade 8. Use Pythagorean theorem to solve each of the following. Okay, let's take a look at the first example here, folks. Now, Pythagorean theorem is based on the largest side, which we call the hypotenuse, which is c. Okay, so in example A, the hypotenuse is the largest side. That's what we're trying to find. So we're going to put down x squared, which is really c squared, equals, it doesn't matter which one you put down first, 3 squared plus 4 squared. Use your calculator or your brain, ladies and gentlemen. You're going to get x squared equals 9 plus 16 is 25. You've already been tested on this, ladies and gentlemen, so you don't have to show me 9 plus 16. You just write down 25. Keep in mind, folks, that this is x squared. How do you get x? You got to take the square root of both sides. So x equals the square root of 25, if you want to think about it that. X equals 5, and my units is centimeters. That's a special 3, 4, 5 triangle. So if you want to write that down here, special, that's a fancy looking star, okay? So this is what's called a special 3, 4, 5 triangle. And you'll use that in grade 11 and 12. Well, maybe in grade 11, but for sure in grade 12. Okay? All right, taking a look at the second example, ladies and gentlemen, if I'm looking for the hypotenuse of triangle B, notice the hypotenuse is given, so I've got to do something a little different. To find the side length I'm looking for, I write down x squared equals the hypotenuse squared, subtract the other side squared. Okay? So what I've basically done is said, hey, if I got to find, for example, b squared here, b squared equals, I'm going to take a squared and bring it to the other side. So it's going to be c squared subtract a squared. So that's kind of what I did there, ladies and gentlemen. When the hypotenuse isn't given, you take the hypotenuse side squared and you subtract the other given side. Okay? So x squared equals, put in your calculator, guys, so just go 7.5 squared, subtract 2.1 squared. That equals 51.84. And again, to find x, you take the square root of both sides. So x equals 7.2, and the units are meters. All right. Question C, word problem. Hey, a ladder. Woohoo, we always have ladder problems, right? A 12-foot ladder is leaning against a wall. So I'll draw a wall. Okay, and I'll draw my 12-foot ladder, so that's what I know there. Okay, I'm going to create a triangle with the ground. What do I know about the ground and a wall? It should be 90 degrees by code. Okay, and it says that it just reaches an 8-foot high window. So what do I know here, folks? That if this is my window right here, this is 8 feet. Okay, how far is the base of the ladder from the wall? Let's let that be x, and we'll do a let statement. So let x represent base distance. Okay, so what we need to do, ladies and gentlemen, is realize in this example here, are we finding the hypotenuse or is the hypotenuse given? Well, the hypotenuse is given and we're finding another side. So you set up x squared equals the hypotenuse squared, subtract the other side squared. Okay, so x squared equals, and in your calculator, go 12 squared, subtract 2 squared equals, and you'll get 80. And take the square root of that, and you get approximately 8.9. Okay, so therefore, let's back that up. Ladies and gentlemen, what do we know about mathematics in terms of feet? Okay, feet measurements are only expressed in fractions, right? Because it's imperial, not metric. So I'm going to take my calculator for a second. I know I for sure have 8 feet, right? But I'm not sure 0.9, how many inches is that? So I'm going to go 0.9, and I'm going to times it by 12. So that's going to be 10 and 10.8. So I'm going to say 8 feet 11 inches. Okay? All right, hopefully Mr. Zachers taught you that in woodworking. Okay? Because when you take a look at feet, they don't have decimal answers, they have fraction answers, or they break the feet into the inches. So here we go. Therefore, ladder base is 8 feet 11 inches from the wall. And folks, had you rounded it up saying it's approximately 9 feet, I would have given that to you as well. As long as you realize you can't have decimals in imperial. Okay? So just remember, imperial measurements can't have decimals. Okay? All right. Taking a look, ladies and gentlemen. We're going to get on to our lesson today. So, intro to trig. All right. So, what we need to do is realize, just like last unit in Unit 7, we'll be dealing with triangles. Okay? This trigonometry is based on triangles. And we got to remember how to label triangles. Okay, you probably saw this when we did the congruent triangles and similar triangles, but we didn't focus much on the side lengths. Okay, so labels on a triangle have capital letters at the vertices or at the angle where the angles meet. Okay, on the angle ends, and lowercase corresponding opposite sides. Okay, so I want you to just stop and watch me for a second. If I label this triangle A, B, and C, okay, before in the past, folks, I would label this side right here where my red dot is, I'd label that AB. But right now we're going to use a lowercase opposite side. So angle C is the 90 degrees, opposite is lowercase c. Likewise, between BC, instead of writing BC, I'm going to write lowercase a because it's the opposite side to the angle. Okay? Same with B. Okay? And that occurs in a 90-degree right triangle or what we call an oblique triangle. Okay? I'll just use different letters here. So I'll go P, Q, and R. These are all capital letters. Okay? And opposite them, you're going to have lowercase. So lowercase r, lowercase q, lowercase p. Okay? That's how you label triangles. All right? Okay? Now, ladies and gentlemen, this box you will see when we review at the end of this unit, and you'll see it your review for the exam. So I would say study for test and exam. Okay, I would also say keep this, ladies and gentlemen. I will reuse this in grade 11 to help you as well. Okay, it'll be very helpful. So I would not lose this piece of paper. Okay, so ladies and gentlemen, we're going to mix a whole bunch of triangles in, and you're going to have to just solve them eventually, not to begin with. We'll start quickly, or start with simple right triangles, then we'll get into obliques and we'll separate them, but then we'll mix them all up. So I want you to know that this is your strategy or your key for solving. Okay, and it's based on the type of triangle given. You want to highlight this box, make this stand out very pretty, make sure it's legible so you can read it. First thing you're going to do is get a word problem, or a triangle might be given, and you have to decipher, is it a right 90-degree angle triangle or is it oblique? If it's a right triangle, you're going to do things like we did in the warm-up, which is Pythagorean theorem. And how do you use that when you've got 2 out of the 3 sides? That was our warm-up for this morning. Or what we're going to do over the next couple lessons is called trig ratios. And this is what we call SOHCAHTOA. And I'm going to explain SOHCAHTOA later on, as well as we'll start that with 8.1. Okay? And when you use SOHCAHTOA is when you've got angles, because Pythagorean theorem only works with side lengths. But this is where you deal with angles within a right triangle. And if you get a word problem that has no 90 degree, then you're doing something different, which is called an oblique triangle. And there's 2 new laws you're going to learn, which is sine law and cosine law, and we'll go over that when we do each lesson separately. You'll understand that a little bit more detail. So for now, just write it out, folks, and that's a good summary for the rest of the unit. Okay? Awesome. Now, when we take a look at trig ratios, ladies and gentlemen, we have to take a look at angles of reference. Okay? So angle of reference, I want you to picture putting your eye on that angle. So for this, for example, angle A, ladies and gentlemen, we're looking at this. If we want to find the opposite side of angle A, that's going to be over here. Opposite, which is going to have short form of OPP. Okay? Now, one thing that's the same from Pythagorean theorem as it is in trigonometry is the hypotenuse side is always opposite the 90. So we use HYP, short form for hypotenuse. Okay? And then the other side length we're looking for is what's called the adjacent. And the adjacent always takes the angle to the 90 degree. Okay? I always think of opposite shooting right across. Okay? Hypotenuse is always fixed, and the adjacent is always taking the angle to the 90 degree. Now, keep the same triangle, folks, and now I'm going to use the viewpoint, put my eye on angle B. From angle B, if I shoot across, ladies and gentlemen, my opposite side is now down here. And my adjacent side is beside me, connecting to the 90, and hypotenuse will always be the longest side that's opposite the 90. Okay, so guys and girls, the reference angles depends on, for example, if you're given a triangle, where the angle is given. So the angle might be given there, or it might be given there, or you might have to find those angles. So it'll say find angle A or find angle B. So angle of reference, or reference angles. Okay, moving along. Now you need to get your calculators out. So for this unit, folks, if I haven't already mentioned, you need a good scientific calculator. If you have one with 2-screen display, it's going to be a lot easier for you to do trig. If you have a 1-screen display, as long as you've got buttons that say sine, cos, and tan on them, you're going to be fine. However, you're going to have to do your operations a little bit different in the calculator. And this is what we're going to do. We're going to practice using our calculator. But before we get to practicing, you got to look, ladies and gentlemen, make sure your calculator is in degree mode. So everybody pull it out. Okay, find one in the house. If you left yours at school, find one at home. Okay, and what you need to look for, turn your screen on. It's either going to say DEG or D with a box around it on your main screen. Very, very tiny, usually on the top. Okay, so either it says DEG or just a box with a D on it. And if you need to change it because it's in the wrong mode, you need to find your DRG button. Okay, that changes it from degrees to radians to gradians. So if you need to change it, press DRG button and keep pressing it until you see degree mode. Awesome. Okay, so now that we've got our calculators out, and trust me, you need to get your calculator. So if you're just pretending to watch my video and not do it, you need to get your calculator out because you need to learn which way your calculator works. Okay, so get it out, and we're going to solve these for each answer to 1 decimal place. Okay? Example A, tan of 48. If you have a 2-screen display or a calculator you bought from Miss R, okay, a nice good one, you press the tan button and then 48, and it's going to equal 1.1. Okay? Otherwise, if you've got an older calculator, you press 48 and then the tan button, and you should get 1.1. Our purpose here is to not compare who's got the best calculator. It's to make sure you know how to use the calculator you have. Okay? All right. Second example, ladies and gentlemen. Either you press in cos button and then 55 degrees, or you go 55 and then cos, and you should get 0.6. Okay? Sine of 86, you should plug in your calculator, you should get 1.0. Remember, rounding to 1 decimal place, so make sure you put the plus 0 in. Now we're a little harder, folks. Okay, so now you're going to press in, if you've got a good calculator, just go 22 tan 67, and that should equal 51.8. If you have a 1-line display, folks, you have to go 67, press tan, and then go times 22. So again, if you've got an older calculator or a 1-screen display, it'll still work. However, you got to press more buttons. Okay. Try the last one, ladies and gentlemen. Plug in your calculator, and you should get 2.6. Now, you're probably saying, Miss R, what does all the sine, cos, and tan buttons represent? And save that answer for when we do this box right here. Okay? So we will use the sine, cos, and tan buttons when finding side lengths. Okay? So we're going to be finding different side lengths of the triangle. Okay. And ladies and gentlemen, notice above, look in your calculator right now, above sine and cos and tan, there's either written in yellow or blue, depending on what color your calculator is. Usually it's yellow or white or orange. You'll see what's called sine inverse, so sine of the -1, cos of the -1, and tan of the -1. You use those buttons when you're finding an angle. Okay? And these are called trig inverse buttons. Okay, and to press the inverse button on my calculator, you need to press, look on your calculator, whatever color matches up. It's either going to be the second key or the shift key or the inverse. You depend on which one you have. Put only the one that you use down. All right. Okay. So because trigonometry deals with finding angles as well as side lengths, okay, I'm going to show you how to do this. So say you're given the expression of tan A equals 3/5. That's comparing two sides. So just to quickly give you an intro to what's happening, okay? On the other page, ladies and gentlemen, you had something called SOHCAHTOA. These are your trig ratios, okay? T, this last trio here, it's called the tangent one. And what the tangent ratio does is it compares the opposite side to the adjacent side. So this is really my opposite side, and this is my adjacent side. Okay? So say you have to build a ramp, okay? And the ramp has to be 3 meters high and it has to be 5 meters wide. Okay? What angle do I have to set that board at so that it will create? Okay, so to do that, ladies and gentlemen, because you're finding an angle, you got to use the inverse button. So that's the tan inverse, which is tan to the -1 of 3/5. So if you have a good calculator, you go second or shift tan, whichever one you need. So it'll say tan inverse, opening bracket, 3 divided by 5, closing bracket, and you should get to the nearest degree, 31 degrees. Okay, angles will be to the nearest degree, and side lengths will always be to 1 decimal place in this unit. Okay, if you don't have a nice calculator or one that takes more steps, or the backwards way, whatever I'll say, this is what you have to do if you've got a one-liner. Go 3 divided by 5 equals, and then second or shift and tan button. Okay, you need to figure out how and problem solve yourself how to work this. Okay, next example, ladies and gentlemen, is cos of f equals 2/7. And again, cos, ladies and gentlemen, it's another trig ratio. So it's comparing the adjacent side over the hypotenuse side. So this is the adjacent side over the hypotenuse side. Okay? So to find angle f, you go angle f equals the cos inverse, okay, of 2 divided by 7. So plug it in your calculator. Hopefully you can figure it out by now. And it should be 73 degrees. Okay, and the last example we're going to have here is the sine of k. I know it says sync, kind of funny, eh? All right, so sine compares the opposite side to the hypotenuse side. And we're comparing those side lengths, okay? Kind of like how you did in similar and congruent triangles. Okay, to get the angle k by itself, it's the sine inverse of this fraction. Okay, so angle k equals 50 degrees. If you're not able to get this, ladies and gentlemen, in your calculator, can't figure it out, star it and say, see Miss R before you start your homework next day, okay? So come and see me for help. It's usually just a quick button to press on your calculator. Okay, so ladies and gentlemen, here's your homework. Page 390, number 2, 6, and 7, and 399, numbers 1 and 6. Ladies and gentlemen, next day we'll be getting into the SOHCAHTOA. We will be dealing more with the tangent ratio to start with, and then we'll get into the other ones. So I just want to let you know where you're heading. Have a great day, folks, and have fun with trigonometry. Aha.